Okay, we're just going to do some simple trigonometry, just sines, coses and tans. So let's start with part A. You recognise straight away that we've got the opposite value to the angle, and then we've also got the hypotenuse, which is opposite to the right angle. So straight away we can write that we've got sine theta is equal to opposite on hypotenuse. So we've got sine 42, theta is 42, equals x on 32. Now we want to get x on its own, so we can bring this 32 over, and because it's dividing, it's got to multiply. So 32 sine 42 equals x. Now that's the same as writing it the other way around, x equals 32 sine 42. So now we just go ahead and work out for x, which will give us, in two decimal places, 21.41. Now if you're getting a strange answer, just check that your calculator is in degrees and not radians. Trigonometry must be done in degrees. Okay, part B, straight away we've got the adjacent, which is right adjacent to the angle, and we've got the hypotenuse. So we've got a situation of cos theta equals adjacent on hypotenuse. So cos, in this case it's 36, is equal to x on 30. Bring the 30 over to multiply. We've got 30 cos 36 equals x, and that gives x equals 24.27. Correct to two decimal places. Okay, for part C, we don't have the hypotenuse. This time we've got the opposite to the angle, and we've got the adjacent to the angle. So that's tan. So tan theta equals opposite on adjacent. So tan 28 is equal to x on 60. Bring the 60 over to multiply. 60 tan 28 equals x, and that finally, if you work it out on the calculator, gives a value of 31.90. Okay, this part D now, it's just upside down, but we've got opposite to the right angle, we've got the hypotenuse, and adjacent to the angle, we've got x. So this is adjacent on hypotenuse, which is a cos problem. So cos theta equals adjacent on hypotenuse. So cos 24 equals x on 81. Bring that over to multiply. So we've got 81 cos 24 equals x. And finally, x equals 74.00 to two decimal places. Okay, looking at the last one, we've got the hypotenuse, which is opposite to the right angle, and we've got opposite to the angle, opposite, which is x. So that gives us a sine problem. So sine theta equals opposite on hypotenuse. So sine 32 is equal to x on 51. Bring the 51 over to multiply. We've got 51 sine 32 equals x, and that gives us x equals 27.03, correct to two decimal places. Now these ones are just a tiny bit more complex, so we just work through them. So we've got the adjacent for part A, adjacent to the angle, and we've got the hypotenuse opposite to the right angle. So that gives us a cos theta equals adjacent on hypotenuse. So cos 41 is equal to 52 on x. So now we've got to bring the x over to multiply because it's dividing. So that will give us x cos 41 equals 52. And then to get x on its own, we bring the cos 41 over to divide. So x equals 52 on cos 41, and that gives us a value of x equals 68.90, correct to 2 decimal places. Moving on to B, we've got adjacent and opposite, so that's a tan problem. So tan theta equals opposite on adjacent. So tan 43 is equal to 8 on x. Bring the x over to multiply. X tan 43 equals 8. Now we want to bring the tan 43 over to divide because it's multiplying. So x equals 8 on tan 43, which gives us a value of 8.58, correct to 2 decimal places. Okay, part C, we have the hypotenuse x opposite to the right angle, and we have the adjacent value. So that's a cos problem. So cos theta is equal to adjacent on hypotenuse. So cos 26 equals 18 on x. Bring the x over to multiply. So x cos 26 equals 18. Now we bring the cos 26 over to divide because it's multiplying, which gives x equals 18 on cos 26. X equals 20.03, correct to 2 decimal places. Before I move on, I just want to bring your attention to the shape of the triangle. So with part C, it's got a very small angle, 26. Now this means that the adjacent value here is going to be not much smaller than the hypotenuse. And the opposite value is going to be quite small. So when you get your answers, you can check this to see if you're way off or not. Okay, let's look at part D. So we've got the angle here, and 48 is opposite to the angle, and this is the hypotenuse because it's opposite to the right angle. So we've got opposite and hypotenuse, which is a sine problem. Sine theta equals opposite on hypotenuse. So sine 62 is equal to 48 on x. Bring the x over to multiply. X sine 62 equals 48. Bring the sine 62 over to divide. So x equals 48 on sine 62, which equals 54.36. So just what I was saying in part C, let's just note that this angle is quite small, 28. You can work that out by the fact that it's 90 minus the other angle because it's a right angle triangle. For a triangle of any kind, all 3 angles must add up to 180. Now because that's a small angle, 28, the adjacent value and the hypotenuse are not too different in value. And so this opposite value will be a smaller value. It's just a way of checking, as I said earlier. Right, now looking at the last one, it's quite a large angle again. So this is opposite and this is adjacent, and this is hypotenuse because it's opposite to the right angle. So we've got case of adjacent and hypotenuse, which is a cos problem. So cos theta equals adjacent on hypotenuse. So cos 58 is equal to 20 on x. Bring the x over to multiply. X cos 58 equals 20. Bring the cos 58 over to divide. X equals 20 on cos 58, which gives x equals 37.74 to 2 decimal places. I hope that's helped. Please like, subscribe and share.